Hey everybody, how you doing today? I hope you're all having a great day so far. My morning has been a little busy, but I guess I can't complain too much. So, yeah, well, I'm happy that it's sunny again today. We're finally done with the rain, but now it's started to get pretty hot. Um, yeah, so I guess can't have it both ways at this time of year. Cool and sunny, but that's what you get living in Houston, I guess. All right, well, let's get to programming. So I was working on the new um, um, terrain system. Sorry, my brain went uh, blank. And I had just rebuilt the asset bundles in preparation for importing the new models, but I don't think everything's hooked up yet. Specifically, I haven't really updated the actual mod files. And yeah, we can see that there was some error. Yeah, the block prototype has no models yet, so let's go and look into that. First off, probably this, I can delete some of these values that I don't need anymore. That had to do with the old terrain system. Just clean that up. I don't think I need to change anything else in here. Okay, what I want to get is block prototypes right here. And so yeah, we had all this stuff with texture claims, but I can just delete it. Yeah, this whole terrain texture doesn't exist anymore. And yeah, all this stuff doesn't exist anymore. All it has now is a name and a list of models. So we'll get rid of all this. All right. Now I'll look into the mod files. Okay, so it's called models, and then we have this block model class. Okay, that was bothering me. It was sticking into my face. Okay, so models. And then we'll have block model. And then path. This will be test content slash. Oh, what is it called actually? Okay, it's this dirt block. Oh, what am I doing? Test content, dirt, block. And I think that it is case sensitive. Yeah, so also there's no space. I think that should be like that as well. Okay, so that's, and then I just need to do the cliff height. Or the deform inset, which we'll just set to 0 for now. Okay, so I'll do the others or do the same thing for the other two, except instead of giving it the dirt block, let's give it that simple hex. And we'll make models for these other two blocks later. So I think that's all I have to do. Let's see if it will load through now. Okay, got some other error. Asset bundle. Test content can't be loaded because another asset bundle with the same files is already loaded. Okay, load bundle corrupt. Okay, so this is from Unity, and then this error is what the game generated. So for some reason it's trying to load this twice with the game. Okay, maybe it's because these are being alphabetized differently. It probably should just be all lowercase. How is it in the files actually? Let's look. Okay, yeah, it's just all lowercase. So I bet that was the error. Okay, so block prototype, no models, so that's not correct. Okay, so models, didn't spell that wrong, did I? Okay, so let's look here. Oh, of course, I didn't add it to the list. So this would be logic, data, models, add, logic model. Oh. Oh no, it's still compiling. Yeah, there we go. That's still an error. Train generator bound. Oh no, so it's trying to, the context is trying to create this or resolve this class, but it doesn't have, or resolve the mouse pick raycaster, but the train generator doesn't exist. So is that what's going on? That didn't actually cause an error though, it's just that the train didn't finish. Let's look into debug. Okay, so that's still fine. And then data, we should see models has model index 0. And then if we look in the game objects, yeah, we can see start block is 0, then simple hex. Okay, so that looks all fine. I think, yeah, we're pretty much done with that. So now we need to do the part that actually spawns these meshes. Okay, let's just trying to think. Because this part is actually not super simple because we can't just instantiate the mesh because later on, like we did in the prototype, I have to actually make a copy of the mesh object and then so I can deform it. But I kind of just want to test the having the objects there, so I'm trying to decide. Probably the class that deals with spawning the hexes shouldn't also deform them. Oh, I don't know. Okay, let's just do this. Okay, so this will actually be a per cell worker. It'll be something like this. And this one will also need the game data. And probably not the temp terrain. Okay, also I just realized... Oh, well, no, let's not worry about that just yet. I was gonna say that we'd only want to spawn models on the stack as long as there's a cliff height that leaves one of the models exposed, but we can add that in later. Okay, so let's see. Probably, yeah, I shouldn't add in extra stuff I haven't actually implemented yet. It's just gonna confuse me. Okay, so we just have create cells. I think that's it. Oh no, we had the complete event and the start work. So yeah, let's just get rid of the ones that aren't used yet. Okay, there was a cell data. Oh, because the complete check. Okay, well, let's just do something that's like will never actually happen yet. Okay, yeah. So here we can leave this the same, except I need to change this to models, and then this will actually do the work. So what I have to do now is just like look through the stack and then spawn a model for each block. That's pretty easy. I guess where should I store the mesh? Okay. I'm trying to think, should I have a different class that will take care of like deforming the mesh? Probably, because otherwise this class is going to be kind of big. Let's see. Well, I guess I don't have to worry about that just yet. Yeah, because if I do that, I'll need to store these models somewhere on the cell data, which is probably a good idea to do anyway, but... Okay. And then layer less than... Oh, I guess I gotta get the cell Okay, so we're gonna go through the stack for each layer. Okay, I guess I'll also need to transform the cell index. Okay, well actually, this is pretty simple. So let's do hex position. So I guess flat position equals hex position from board. Okay, and then we can just add the layer onto this. Okay, so game object. Equals let's actually drill down a little farther. So prototype ID is cell stack layer, and then model ID is the block. Oh no, it's database block prototypes. Prototype ID. Oh, and then I gotta find the right model. Okay. We also need the layer. Okay, and for now it's really just going to be as simple as returning the first model. I guess I should return the index actually, because I'll need the cliff length. Okay, so I actually just return 0. Alright, and then I can get the model object is database block prototypes. Models dot model index, and then from there I can do database game objects model dot model index. Okay, let's change the name of this to block model index. Okay, so now I have, this is the game object, this is actually the prototype. And then I guess I'll instantiate this. Okay, so game object. Okay, I don't know. I need to parent it to something. How would we get that information into here? Okay, so we'll need to have something. Okay, so this will just be a mono behavior that really will just be apparent to all terrain blocks, and won't really have anything else that it does. Okay, so now I can pass in the parent here. Okay, so now I can give it the position. Okay, what is the class that does that? It's X positions. Okay, I don't think I want this. Maybe I could just do new hex position flat dot column flat dot row, and then the layer to Cartesian. And this just transforms this hexagon position to to the XY plane. XYZ plane, I guess I should say. Or XYZ space, actually. And so I think that's about it. Later we'll need to store this game object because we'll have to add the mesh and everything. But if I do this, we should start seeing these models. And that will be good. Okay, so... Context, resolve, model, creator. And now I just need to add the block parent to this terrain. So I can get rid of this class, actually. Block terrain. Once it's done recompiling. Alright, it's block parent, actually. Okay, so I think this should work, but we'll have to make... well, I guess we'll see. Okay, no. Object reference not set to an instance. Okay, so either this is null. Well, I guess this must be null. Or database is null. Oh yeah, the database is null because I don't set it right here. Okay, so there's some things. Oh. Okay, so that's interesting. I guess, yeah, the hexagon radius is larger than in the final game. Or it's larger than it was in our prototype, but everything else looks right. Done the altitude correctly, except the... Okay, yeah, so the dimensions for this thing are all off. But we can try and fix that. We probably won't use this model in the final thing, so I'm just gonna, you can scale it. Okay, so let me see. This is 1 by 1. And I think that the radius is 1.5, and then the layer height is 0.6. So I can just add this in. So we'll scale by X and Z by 1.5. Oh, wait. Oh no, because of the rotation, Z is actually up in this case. So here we need to do 2/3. And I guess I should do the same thing for this simple hex. Okay, and now I'm gonna need to rebuild the asset bundles because there's been changes, so it's a bit easier to do now. It'll just take a couple minutes or a couple seconds, but it'll be okay. All right, so let's see. Well, really, the next thing we gotta do. Yeah, we'll need to take care of this. So we'll need to do the hex deformations. In order to do that, we'll have to figure out the cliff heights. So cliff heights will probably be our next step. Okay, I guess, yeah, usually when it's done, you can interact with things again, so. I still want to have this open. Then you can just drag all this into here. Alright, so now that matches up better. Oh gosh, I hate those shadows. I don't... Yeah, we just need to play around with the shadows a lot. I don't know. I think it's my shader, but... Oh, actually, no. My shader is not on these, so... It does look better on the... actually model blocks. I guess just flat terrain doesn't really mesh well. Or flat hexagons don't mesh well with the shadow system or something. I don't know. This is looking pretty good. Probably in the final one. Well, since it's stretched out, the mesh has been distorted, but probably we should exaggerate the separation between these hexagons a little more. Because right now it looks sort of like it's not intended. But yeah, that's an artistic thing. You might be wondering why the models aren't here, but that's just because the game hasn't actually reached the placing yet because the terrain system never signaled it was complete. All right. Okay, so let's find a cliff links first, and then I know I'll need the hex corners for every hexagon for the collision mesh, so I think I'll make that a separate step where we'll find the corners for each hexagon. Okay, so let me see. Okay, so for cell task, we'll add in cliff heights. And then I know I'll need these corners, so we already have cliff heights, and then we'll need to have vector 3. I could even put the position, like the anchor for the cell in this. So maybe I shouldn't name it corners. I should name it, I don't know, points. So this will just have the centers, because that will be, yeah, the model creator can use the center point to position itself, and then it'll also have the corners. So let's see. So I guess 0 is bottom center. 1 to 6 is the bottom corners. And I always start from the top corner or the northern corner and go clockwise, so that'll be obvious. And then 7 is top center, and let's see, I'm gonna count 8 to 6, 8 to 14 is, that's actually, yeah, 8 to 13 are the top corners. Okay, so this array will be 14 points, which makes sense because 6, so yeah, 12 plus 2. Okay, but anyway, we've got to do the cliff heights. Well, these can actually work in parallel, so that's a good thing about it. Okay, so this will be the cliff finder. And it will again work on a cell basis. So let me see, probably, yeah, we'll just need the battle. I won't need that temp list again, but okay, so let's see. Yeah, this can run once the stack has been generated. Actually, well, this will be fine because I was going to say it doesn't really actually need the stack, but the stack also encodes the elevation, because otherwise we'd just be doing that twice. Okay, so I'm kind of scared to open up a second version of Visual Studio because last time it messed up the font. And that other font was kind of hard to read. So let me, I really only just need one file from the blocky terrain. I just want to see that hex scalar. I'll just open it up here. Oh, that was the wrong file. That's the meta file for it. Okay, specifically, where does it find the cliff faces? Or how does it do the cliff faces? So for every neighbor, it calls us get cliff height. Okay, and then it does get surface altitude. Okay, so yeah, we're gonna have to, I don't really want any cell to ever have to look into data about its neighbor cells if I can help it, because because that introduces a bottleneck. So probably the easiest way is just to make the code that gets the surface altitude be in a separate static class. Or not even a static class, but it's a helper. Let's see, so altitude finder. So this will need the battle, but that's it, I think. And it'll have public get. Okay, and then we'll pretty much just copy this. So we've got the layer size, number of layers. Okay, so if the proto ID is ever 0, which means it's air, then we know that this is, or the layer below us was the top, so we can return L minus 1, and then if we get through the whole thing, then we would return the number of layers, I think. So let me see. Yeah, because... Oh no, it'd be number of layers minus 1. Because, okay, say we have a 3-layer map, then the first layer is 0, obviously. But if every layer is taken up with a solid hexagon, then the altitude is... Okay, well, altitude is actually 3. But do I want to give the highest block or the actual altitude? So it's kind of just semantics, but I think this will be better. Okay, so terrain stack generator. You can probably make this a little easier. So we just get a reference to this class. Okay, so now I don't really have to test this because we always know that it's never will be air. Also now I don't need this temp train because now we know the number of blocks that will actually be in the stack. Okay. New int num layers. See if I can type the right letter. Okay, so now I don't need that, and I don't need to do that to array at the end. Okay, so that's a bit simpler. And then this cliff finder, we'll just need to get the altitude finder. Let's just regenerate the constructor because I don't want to type it. Okay, so anyway, we'll still need this get cliff height. Okay, so this is a neighbor hexagon. I can just change this into a cell index pretty easily by just giving it the board. Okay, so this will actually be the layer, or let's call it the neighbor highest. This is valid. I think that's actually built into the hex position. Okay, so I can still use this max because we don't ever want a negative cliff height. Oh, I see. So, okay, let's change this. Okay, so now this flat hex position won't have the altitude built in because that will complicate this a little bit. And then saying, yeah, if it's not valid, then we just take it that we're on the edge of the map. And then to get the cliff height, okay, so all we gotta do is loop through every corner. Okay, so int my highest. Well, it's really the same as this terrain stack. But I guess if we don't use a terrain stack, we can run at the same time as it, so we might as well. Altitude, get highest layer, cell index. Okay, and then cell dot cliff heights. Okay, then we need to get my flat position. Oh, okay, and that was just for testing, but we don't have to, we have a better way to test now. Okay, so that's really all this has to do. Okay, so this should be cliff heights, and now it has no dependencies, so it can run right at the beginning. Okay, so the block terrain, I've got to add that the altitude finder here, and it has to go before, so that way anything that needs this class can be dealt with later. Oh yeah, it's also not a worker, so we can just resolve it right there, and I should change this, oops, if I can, to resolve and bind. So this means it will create a new instance of this object, passing any dependencies, and also binding it into the context so other classes will be able to use it. Workers add context resolve, and this will just be the cliff finder. Okay, so let's play the game and see what comes up. Oh, something is null. Oh, I bet I know it. I already know what I forgot to do. Again, I didn't instantiate that array. So cliff heights equals new. Oops, it should be 6. Because yeah, there's one cliff for every side, obviously. Okay. Why are some things not created? Let's look. The cliff heights seem to be fine, but okay, well, let's see. Yeah, that's very strange. Okay, so we're missing quite a few blocks. Yeah, it's not like they're invisible, they just didn't get created, but how come? Oh, it says they have a stack size of 0. Oh, I think I know why. Okay, so the train stack generator. Yeah, we need to check if it's less than or equal. Okay, yeah, so the number of layers is the highest layer plus 1. Okay, so that was my mistake there. Alright, so now everything's... Yeah, before it just wasn't creating anything that was only 1 layer high. Which is why there was that strange pattern. Okay, so next step is to figure out the vertices or for every corner, or I guess we just need to figure out all the points. So, see here. It'll work a lot like this. It'll just need battle. I think it will need the altitude finder again, because we will need to know the altitudes of our neighbors. I wonder, should I just have that already? Well, actually, no, that's encoded in the cliff height. So I won't need the altitude finder. Okay, that's kind of good to see. Okay, so this will be points. And it has a dependency. We need the cliff height And I think that's it. So this says if points is not complete, and cell dot complete and cliff heights is complete. Then we'll do work. Okay, so there's a couple things we have to take into account. Right now I'm just going to do it the simple way. We'll add in, how should I explain this? So, I guess let's just load the game in again. It should still work. So right now we're going to figure out the points of the deformed hexagons. And basically, the higher a cliff face, the vertices will move inward a bit just to add in a little bit of flavor and to make it not look quite so blocky. So yeah, like right here, since this cliff height is height 2, this corner would move in a bit. The only complication is here. So these two are at the same height, and so right now the game would treat that as not wanting to move in this corner, but it can actually go in the middle so that they still touch, but they move away from this hexagon. I don't think I'm going to take that into account, although I kind of know how to do it, but we'll just go with the simple way first because we want to test that out. And again, I can use this. So I have this deformed corners. First, I guess we can figure out the center points because that's pretty easy. Okay, and so cell dot points is a new vector 3 with 14. We have the two, so center and 6 corners for top and bottom. And then, so cell dot points 0, which is the center on the bottom, is just my flat hex position. Or wait, do I want to do it? I should do it in local space. Yeah, so this is fine. Okay, well in that case, the center is 0, 0, isn't it? Okay, well that's fine. And then 0.6, which is the top, is just the height. So do I know that? Let me see. Okay, what's this in the board metrics? Okay, so I guess I will need the game data so I can get a handle on that. So yeah, it's just up one layer. Kind of simple, but... Okay, so the inset amount is just the minimum cliff height between myself and or between the two cliffs that are adjacent to this point. So this is the cliff that's counterclockwise, and then this is one that's clockwise to the point. So I gotta change this to cliff heights. And in order to detect if I can slide inwards, I would see that, okay, this cliff height is 0, but then this cliff height is lower. Then I could scoot inward parallel to this, to my neighbor. There are some other... that's kind of interesting. There are some other complications too. I wonder... okay, well, we'll just have to figure that out. I might need to change some of this stuff now that I think about it. Well, let's just get this working. What I might need to do is, instead of... I don't know the best way to handle this. But I'm thinking that... let me see here. This takes a while to load up. Okay, so say we have a situation. I don't even know how easy this will be to draw, but got one hexagon here, and then we have this neighbor. But then this neighbor... okay, and then... yeah, I can't really draw it like this either. Well, let's just not worry about it. I'll probably have to change this code, but it'll be fine. Anyway, okay, so the undeformed is just the corner direction times a length unit. Okay, and also the slope inset, I decided to make it a bit more complicated by having each terrain block have its own slope inset. So now I'm wondering, maybe instead of storing the cliff heights, I should actually store the cumulative cliff inset. Because I think I'll need that. But I don't know if that's really worth it to store. Because it's not that hard to calculate. I could just add that to the altitude. Okay, so we'll still need this. Don't really need that. So L less than or equal to... well, actually, I'll need a lowest layer too. Okay. So let's see. Float inset equals 0. Okay, now I need the database. Could also just figure this out when I'm doing the stack and store it. Because that's basically, I'm using the same data. I'm trying to figure out what would be the easiest to do. Because I kind of need to know the inset at each layer. Because if we join up with different blocks, the inset that we would want to match could be different. Okay, let me see. So maybe this stack, we can just have another simple little class here, serializable. This will never need to be changed. So this will just be the proto ID and might as well just make it a class in case I ever do want to add something else here. And then the inset, well, oh no, this will be the cumulative inset. It just means it takes into account the insets of all layers below it. Do you want to have it that way? Oh, I guess I have the cell like that. Okay, that's fine. This is probably a good idea because, for example, I'll need to store the mesh in here for later use. If I really wanted to, I could have a different class come in here and add in the cumulative insets. I don't know, maybe. Oh, why am I typing this out again? But I mean, it's pretty simple. Okay, so float inset equals 0. Also, I should maybe make it clear that this is the inset at the top of the block. Because at the bottom of the first block, it's by default 0, so we don't really need to care about that. So inset plus equals database, which I don't have a reference to. Okay, so... Oh, also this depends on the model. Okay. So we've got to figure out the model first, and then we would do the... Okay, so I can't do the inset now. Yeah, so yeah, good thing I did decide to separate this out, because yeah, adding in the models does complicate it quite a bit, actually. So let me see. This model creator, I want this to just handle instantiating the mesh, so I was gonna have it pick the model, but I don't really want, since this model is gonna be more important, I kind of want to separate it out. It just feels better. Let's change this to model index decider. Okay, and this will again. Well, actually, I could just pretty much use this as a starting point. Oh, except I don't need that block parent. Alright, and then in this block I should add in public int model index. Okay, so when can this work? I guess after the stack is generated, and I gotta create my own flag. Okay, so this would be model index, and let's change this to model mesh. Okay, so if I generate an enumeration member, will it... Okay, it does actually add in the flag value, so that's nice to see. Okay, so all I have to do here really is... yeah, just set this, so, okay. L stack, let's do it this way. So far, block equals cell stack L. And the proto ID, I don't really need to do that actually. So block dot model index is pick model, and then block proto ID. And that's it for this. Then if we go back to, oh, this is the model creator. I'm doing the wrong thing. Okay, let's copy. I always do this and just undo. No. Okay, and then back to the model creator. So all I have to do really is just this part. I guess I'll still need to get the block. Okay, there we go. Okay, so now this is good. Then I'll need to have like an inset creator. Okay, so probably, yeah, we won't use this. Let's go ahead and just add in that, add the model and index finder. And see what happens. So now the cliff finder, oh no, it can run right away because it doesn't wait on anything. But this model creator now needs to wait for the model indexes. All right, we can get rid of this. Oops. Point generator. Oh yeah, this isn't done yet, but get it a bit to recompile and then we'll try again. So got a null reference right away. No object terrain generator brown. Oh, that's just the mouse. The model creator. Okay, so let's see. Do I set database and then? So it's saying that the something is null here. Okay, that's just doing the model generation. Oh, or the terrain generation, I was just making sure. Okay, so for some reason, either models is null or the block, or this block is null. That could be it. This model creator. Okay, it waits. Create cells and then the model index to finish. Oh, but wait. Yeah, I didn't finish this part. So this should check. Still not sure why it ran, but model index is not done and cell complete and okay, so this needs the stack. I guess the other thing that could have happened is I didn't set the stack, which I did not. Okay. Yeah, I always forget to do that. Okay, so now we've actually got it to run again. Let's see, so... Okay, what's going on? It's super slow. How come? I bet one of the terrain classes is running every frame or something. Let me see. Oh, is it like... Yeah, I think it's like creating models every time, every frame. And that's why the render is so... taking up so much time. Okay, well this is supposed to be cell complete and cell model mesh. Yeah, so it should stop working when I set this here. Let's just make sure. So, bug log. I see this printed every frame, then we know this is the culprit. Okay, so it is running every frame and creating tons of models. Why is it doing that? Because I set it right here. Oh, well, wait, was that? It does have to run for a lot of times for every cell. Although, yeah, not 1,000 times. Okay, it still is running every frame. So why is that? I guess complete is getting overwritten somewhere. Equals, 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 does not equals. I don't see any problems here. Okay. This is a weird thing. What's going on here? Okay, maybe it's actually creating a new block or something. That still wouldn't make much sense, but okay, so the model mesh is part of that flag. But okay, so something's wrong with my logic, I guess, because model mesh is set to true, but it's still going through. Let me see. So 1 shifted, 1 is 2. Okay, this is gonna be a dumb mistake, I'm sure of it. So does anything change after setting that? And for actually the first time, okay, yeah, the first time it doesn't have model mesh in it, but for some reason it still works. I don't really know why. Okay, I guess a safer way is to check it if that does not equal model mesh, although it shouldn't be needed. Because we're doing a bitwise and there, but okay, yeah, that didn't make any difference. It's still running. Okay, so this happened first time, and then it adds model mesh to it, but then it still runs even though model mesh is set to done. So something is wrong with this, but I don't know what, because I mean this code still works. I mean, oh, okay, this should be equals 0. Did I really? Was that really the thing? Sorry if that was an issue. It is the end of the week. No, okay, that wasn't it. It's still going. Okay, so yeah, this means that if this flag does not contain model mesh. Oh, this is or. Okay, that was the issue. It should be and. Can I do that somewhere else too? That's not. Yeah, and. No, I'm. Okay, I don't know why I did or there. Okay, so that's kind of confusing. I mean, kind of annoying. Hopefully this will fix it. Okay, there we go. Sorry about that. Okay, so now that's done. I guess I should actually check the values that are entered into the debug. Okay, it's still compiling. Okay, so we've got proto ID 1 and model index. Well, I guess they'll all just be model index 0. But yeah, no errors so far. Okay, so now I can have something that will figure out the cumulative insets. Okay, so the insets is kind of annoying as well because they're different for each side depending on the cliff height. Okay, so what I actually have to do is change this to an array, and it'll actually be an array of 6. That's not that big of a deal, I guess. And this should be a float too. Okay, so let's see. Inset calculator. Let's start with this as a base. Because we'll need, well, we might not need the battle for this one actually, because we're just going to be using the cliff heights. It's already generated. We'll just generate the constructor later. Okay, so this one will need, okay, so let's do it this way. Private, static, cell tasks. What's it called? Dependencies. Okay, so we need the oh, that's not the right way to do that. The model index and the cell are cliff heights. Okay, now I'm going to shorten this to that. Okay, so first we'll check that insets has not been created or has not been finished. And we'll check to make sure that the dependencies have been finished. And the way you do that, you actually need to check if it equals this, because that means that this complete has every flag that's in the dependency. Okay, and then you can add that in later. Just making sure that number worked out right. Okay, don't need a pick model. We've got an extra curly brace there, so let's delete that. I don't need the... Do I need the hex? I'll need my neighbors. Oh, well, I don't need that. Because I know the neighbor's cliff heights based on my own cliff height. So, let me see. Int highest layer equals cell stack length -1. Okay, I can do it like this. Okay, so block dot cumulative inset. Okay, actually, to make this a little simpler, let's do it kind of backwards. So int corner less than 6 corner. Okay, well, I guess first I'm gonna need to create these arrays, so do that. Okay, and they're initialized to 0 automatically, so that's kind of nice. Okay, so for each corner. We'll just need to add up the insets so far. Start to 0, okay, and inset plus equals database block prototypes block dot proto ID. Oh, I did get the model index. I guess we could just add the stack in there too, although it's kind of redundant. Oh, also, okay, we'll do that in a second. Okay, and then I also have to make sure that the cliff at this layer, well, there is a cliff at this layer, so let me see, how would I do that? If cell dot cliff heights C. Okay, so the cliff height, there is a cliff if this layer is, okay, so the highest layer minus the cliff height. Or I guess if the layer is greater than or equal to the highest layer minus the cliff height. Because this would actually give us the cliff start. I can add this in here. So cliff start. Okay, so let's see if there's a cliff of height 0 or of height 1 and it starts on the second layer. So this is the first. So when L is equal to 0, then it would be the highest, which is 1, minus 1 for the cliff height is 0. So I actually need to wait until the layer is greater than this cliff start. Actually, I can do something like this, can I? So this is cliff start plus 1. Because, yeah, we won't have to add anything beforehand. That makes this simpler. Because before the cliff starts, then every, the inset's always 0. Is that true, though? Well, it is true in the simple sense. Okay, so just trying to think. Let's just get the simple way working first, and we'll go back. I might need to actually calculate this a little differently if... Oh, right, because, okay, this inset is per corner, but the cliffs are per side, so I also need to do this a little different. Where was that? Point generator. Yeah, so I have to kind of take into account both of the cliff heights. Okay, so maybe actually for the inset I should have like an inset. How should I encode this? Because the inset either goes completely inward or it goes along parallel with the edge. And it's inward if there's a cliff on both sides, but parallel if there's only a cliff on one side. Okay, maybe the inset should just be a vector 2 instead of a float. I think so. Okay, this will be kind of interesting. Okay, so I definitely want to have these just be plain vector 2s and the XY plane, or actually XZ plane. But when I'm calculating here, it might be easier to keep an inset for like an inward inset and then a clockwise and a counterclockwise because they might like add together in different ways. Okay, so let's see. Hopefully this will be fine. What should I call this? I guess clockwise. Inset is vector 2, 0. And then I don't really want to... Okay, I'm just going to go the British way and call this anti-clockwise, just because it makes it more obvious that these two are different variables. And then we'll have... What should I call this one, I guess? Inward inset. This one will go towards the center. And again, we'll just add these based kind of on the different... Like if there's cliffs coming on both sides or just one side. Okay, so I should figure out this cliff start both for the clockwise and anti-clockwise. And clockwise is, yeah, the same. And then anti-clockwise cliff start. Oh, this shouldn't be an equals, this should be minus. Okay, and so for this I need to go counterclockwise from this corner, which is the same as adding +5 and then doing a modulo 6. Okay, so this will give us the clockwise for, or the cliff heights for the clockwise side, which is here, and then the counterclockwise are anti-clockwise. Okay, so I guess we could be fancy and do like a minimum of both of these, but I don't know. Okay, so now we need to figure out if this layer has a cliff both clockwise and on the anti-clockwise, then I would do an inward inset. If it's only on the clockwise side, then I would do, okay, let's see, if there's a cliff, there's a cliff, so if we're doing this point and there's a cliff on this side, but no cliff on this side, then I actually need to move in. Yeah, so this is the anti-clockwise side, then I need to move in on the clockwise direction. Also, okay, how do I deal with my neighbors? Because I also need to make sure that we have the same, and the insets need to be like averaged between both of them. Okay, this keeps getting more and more complicated, doesn't it? So if I want to do that, then I kind of need to know what model, and I need to know the stack of the other cell. So, because we've got to make sure that the points match up. Okay, so how do I want to do that? I guess I'll just need to get the neighbor cell. I think it... Let's see, so if I just do it the simplest way where we only have an inward inset, then I don't need to worry about my neighbors. So maybe I'll just go with that first and we'll get it working, and then we can add in these fancier insets. So I guess I'll just leave this here. If block... Okay, so if L is greater than the clockwise cliff start and L is greater than the anti-clockwise cliff start, then we would do this. I guess an easier way... It's a little redundant, but it's okay. Oh yeah, and this inset, I need to do the inward inset. Okay, and then the direction is... That's vector 2, inward direction is... Well, if I'm gonna have both these vectors, I guess this could just be a float after all. And then we could just multiply it by the inward direction, that way I don't have to... Oh, does it really matter? Let's just keep two vectors. I don't know, I'm making this more confusing than it needs to be. Okay, so anyway, this is the hex position, get neighbor our corner direction. C, and then I just need to invert it. That would be something like this. Let me just add it there. Okay. Let's add this class. I mean, this is, again, just the simplest way. Because at this point, we don't care about our neighbors, but if we try to add in those fancier insets, it makes this logic a lot more complicated, and we have to start worrying about matching up with neighbors. And just for some testing, I think I should make some of these have different insets. So let's keep this 0.1, and then stone will have 0, and then grass 0.2. Let's make it 0.25 actually, so they're very different. Alright, and now so block train generator, I just need to add the inset calculator. Oops. Okay, so hopefully it won't crash and burn. I mean, nothing really will look different, but we'll be able to see the inset values in the debug. This would be a good place to start. Okay, so we did get an L reference. Oh, I forgot to create the constructor. Okay, so we're gonna need to try this again. Let's turn off collapse. But of course, while it's compiling, it won't respond to anything. Okay, so no errors this time. Well, there is one, but that's just the mouse picking, complaining that it didn't get the terrain generator. Alright, let's look here. So we should see an inset. Yeah, that's like barely anything. Also, yeah, this isn't right. Okay, so what this is go to the scene. 0, 1, 2, 3, 4. So yeah, it's missing a Y component, and there's not even a cliff there. Let's look at this one. So this should be, oh, this is actually element 1, but no, that's, yeah. So this element 2 should have 2 things in the stack, which it does. Okay, so how come they don't have a Y component? Oh, again, it's that weird XY problem. Okay, so let's just, so I don't have to worry about this, even though the Y component is never going to be used. I'm just going to change these to vector 3s so I don't have to keep on converting back and forth. Okay, that should fix that one error, but the layer has to be greater. So what about at that, the first thing? So there's a 1, cliff height of 1, and the highest layer is 0. So I guess this would be -1, so 0 it would be greater, so that should be okay. But it seemed like some of them weren't working, but maybe that's just because the Z axis wasn't showing. Okay, so yes, this makes a bit more sense to me. But okay, so this is element. Check this 0. Okay, so this is saying no. Yeah, so no cliff height here, or no inset, no inset, no inset. Okay, and then these 3 have an inset. That's right. Oh, and then this one is saying that only element 4 has an inset. So 0, 1, 2. Oh, yeah, sorry, I counted that wrong. So this shit is actually element 3. So that is right. And then at 2. Yeah, this one has, yeah, so 0, 1, 2, 3, and 4 have an inset on the second layer, but then on the first layer, only this one does. And do they add up? Oh yeah, they do, because this is 0.2. Okay. It seems like that is it. Okay, so let me write some notes here. Let's see, so we've got loading models. Did that? Oh, we can add that later. It's startup. We're working on this. Okay, so I need to, for the insets. Okay, let's rename this. So clockwise and counter clockwise insets, taking neighbors into account. Insets must match up. They'll need to like average between them. And then I also, I just gotta do the deformations. Yeah, so I'll just say implement deformations. But yeah, so we're kind of at a good stopping point now. So I guess we'll come back and we'll just do the deformations with these simple insets Monday, and then start on probably doing these more complicated ones. After that, we'll pretty much be up to where we were on the prototype. After that, we'll need to do the collision mesh, which is just going to kind of be like the mesh for the old system, except it will use these deformed points. That's why it's important to have those. Which, now that I think about it, okay, these points need to also be per block. But the points are really as simple as just finding the hex corner and then adding this inset. So I wonder if I even need this. And the centers are just 0, 0 actually, so let me see. Remove. Well, actually, I'm going to go ahead and do this because, yeah, we don't need those points now that I think about it. Because the points should actually be per block. And it's really easy to generate them. So let's get rid of that. And this point generator, just delete. And block train generator. Okay, I didn't even add it yet. Okay, so I can get rid of this. Okay. Yeah, so we'll need to do the collision mesh, and this view blocking mesh is kind of similar. It's just going to be a black visible mesh that's inside the terrain so that we can't see through any cracks. And yeah, we'll want to support rotations. This is actually kind of complicated. So maybe I should do this sooner rather than later. I'll move that up. Because I want to be able to rotate every model to kind of keep things looking more varied. But I have to keep that into account when I do these hex deformations because I need to make sure that the insets match up even after being rotated. So yeah, it's a little more complicated than first glance. But anyway, I think I better get going and get a bite to eat and then get some work done on offline stuff. But yeah, thanks everybody for coming by today. I really do appreciate it. I hope you all have a great weekend. Feel free to follow me here on Twitch or on Twitter. I always post when I go live, which will be around Monday at noon Eastern. I also have a YouTube channel if you'd like to catch up on the stream or just see how the game used to look. And a Discord server. You can chat with me throughout the day. I'll try to be there most of the weekend, so feel free. Hey, Adlioko. Sorry, just leaving, but thanks for stopping by. But I'll put links in chat, or you can also check out the video description if you're watching from YouTube. And I think that's about it. So yeah, thanks everybody again, and have a great weekend. Bye-bye.